Okay, so today I'm going to talk a little bit more about the interest rate risk management. Actually, there are two methods we're going to learn to hedge the risks. First is the cash flow matching. That's when you really try to match your out and inflows. For example, if you have a debt and you have to pay 100 euros in the future, let's say in 1 year, then you try to invest in some bond or whatever that pays you 100 in 1 year. So you have the outflow of 100 and inflow of 100, so the interest rate that might be changing during that year doesn't affect you. But of course, that's only theoretically very nice, and in practice very hard, because when you're a big company, you have a lot of outflows, a lot of inflows, and it's not always just 100 euros, but more complicated numbers, so it's really hard to match it over the time. So immunization is a rather practical approach that we're also going to have an example for. That's when you try to have the same present value and the same duration of commitment to pay, and thereby you try to match up what we're going to do. But we'll look at an example so it's easier to understand. So in this case, we have an old woman that's retiring, Miss Caselli. She can invest $1 million for her retirement. So the two options that we're going to face right here is rather in 6-month T-bills or 30-year T-bonds. So those are, of course, two extremes. I'll go up. Yeah, sure. Yeah, sure. So, do we have chalk? No. There. So those are the two options that we're facing here. Either it's 1 million and some T-bills, or 1 million in 30 years T-bond. So when looking at what happens when the interest rate changes, for example, if you have the 6-month T-bills, the first interest rate we assume to have would be 4%. So that's the interest rate we invest at. So if we only live off the interest, we get 40K. So if the interest rate falls down to 1%, you immediately just get 10K interest. So in terms of the retirement plan, where she really has to live off the money that she's getting, it's of course a very dramatic fall. At the same time, if we think of the T-bonds, where she also can live off the whole substance she's investing, so there are more funds. Of course, okay, we have first to look at the duration. So the duration is the actual time it takes to pay the real costs you invest. So for this bond, I said it's a duration of 17.72 years. And in this case, we assume the interest rate is not falling, but increasing. Again, from 4%, but this time it goes up 3% to 7%. So you can say with the duration and the invested capital and the 3% that it rises, we would lose 531,000. That's half the capital she invested. So in the beginning, she invests more, so she can live off more, but at the same time, it's risky because she can lose a lot more. But of course, those are the two extremes, as I said. So as often in life, the truth lies in the middle, so we have to make a kind of a mix. So this is the consumer side. So if we think about the financial institution that pays her the money, in terms of the T-bond, we have to say that the 1 million that she invests is the present value. And then we get 27.5 $27,767 that they pay her every half a month. It's compounded semi-annually. Because it's 30 years, 60 payments, half annually. So that's the payments that you will receive. And now we look at a strategy to invest. That's the XT. The company that gives her the loans always tries to invest with the same strategy. So they will invest XT% into the 30 years T-bond, and the rest, which is of course 1 minus XT% into a cash discount. A cash deposit account that will compound overnight. So we set the duration for the T-bond is 17.72. The cash duration of cash is 0 because it's liquid, it's available right away. And the duration of the annuity that they promised to the old lady is 12.34. So as we see, this is times 0, so this cancels out. And then we just divide 12.34 divided by 17.72. So we find out the company has to invest 70% into the 30 years T-bond, and the rest, oh no, it's actually 71%, excuse me, and the rest to the cash account. So there are certain rules. Let me see, is there? Put this away again. So the company now knows what to invest in. First point. And there are certain rules. So as we said, they have to make the coupon payment. So they collect per percent divided by 2 coupon from the 30-year T-bond and the accumulated cash interest. That's what they get. They, of course, pay Ms. Caselli this, and then they reinvest, because then it's, of course, a new situation, to the rule where percentage of long-term bond, which is the XT, equals the duration of the annuity divided by the duration of the long-term bond. Okay, so what we see with this rather dynamic approach, that you have a nice mix between the liquidity and the long-term bond. Of course, as I said, the mix is the better option most of the time. So we can now look at the table. It's probably rather hard to see. Maybe you can look at the slides after the session. It just shows T always in 0.5 steps, because as I said, every half a year they get something. The second column is the interest rate. They have different interest rate because what we want to find out is how it changes when it's not 4%, when it goes up and down, but I think, yeah, in the end it goes down as well. Then there's the 1 million they start with, and of course they pay. Then there's the present value of the annuity, the duration, and the same for the bond, the present value, and the duration, the interest payment they make. I mean, if you look at it, probably have to take some minutes for yourself, but then you really see what it does when the rate goes up and down. Yeah, exactly. As I said, it's better because you have liquidity and low transaction costs, and you always have to calculate it new, but it's better than just one extreme. Exactly. So in the beginning we saw when you just invest in the long-term bonds, it's bad when it increases the rate because you invest for 4%, then after a few weeks it's 7%, so your bond loses the value, and for the cash it's the other way around. When it goes down, it's bad for you because you effectively collect less, so you have to make a mix. So those are just some historical data, how much the interest rates were changing. If you look at the interest rate itself, it's close to the normal distribution. That's what they try to show. So when you hedge risks, you can always be in the middle. It's not too extreme, but of course you try to save yourself against the extreme reactions of the markets. So those are just performance strategies. I think that's the one we chose, the dynamic one. For example, A, if you just invest 100% in T-bonds, most of the time you lose money up to 3 million. Then the 70% we chose is much more skewed into the right direction. We of course want to make money. 30% in T-bonds, again, rather skewed to the left. And that just shows, I mean, you can play around a lot of times with the different mixes. Important is just that you don't just get 100% in cash and 100% in T-bond. So the next topic is the asset liability management, because we also have to save those against the interest rates. So those are the firm's balance sheet. Of course, if you have the equity and assets or liabilities, you can calculate the other ones, or the other way around. And say the most important formula. Is when we find a mismatch between the assets and the liabilities. So the duration of equity, assets divided by assets minus liabilities, which is of course equity, times the duration of the assets minus the whole thing with the liabilities. And that means that the dollar duration of the assets equals the asset itself times the duration of the assets. And we often find a mismatch to the liability duration. So what that means is that example, we have total assets of 2.4 billion with a dollar duration of 19.74, total liabilities 1.8 with a dollar duration of 5 billion. You just subtracted, so the market value of equity is 600 million, but the dollar duration is 14.74. And this of course means that you're again sensitive to interest rates when they rise or decline. So their example is 1% up means that you're already losing 147.4 million. So what you have to do is you have to look at your balance sheet and calculate, if you have the amounts and you look at the duration. Cash, of course, has the duration of 0 again because it's liquid. Short-term loans, they can be 0.8, 0.5, of course, very, very little number. And with middle or long-term, the duration gets longer. So again, we have a mismatch here. The assets are 19,740, and the liabilities are 14,740, so a mismatch of 5,000. So what you could do, for example, is invest more in long-term liabilities, or we already looked at the swaps where we can change different kind of risks. But the most important thing, again, is just that you're aware of it. You have to constantly monitor it, and you have to know all the effects. So I think, yeah, this was the last slide. So thank you for your attendance. Thank you. Oh yeah, any questions?
Next presentation will be just one subsection, 3.7. Any volunteer? 김민영 and 조현정이 지금 유정빛 you. And then next homework is to take lecture of this link. Next lecture is what? 3.5 to 3.8. So yeah, here to here. And then let's discuss last week's topic. No, topic on which you took a lecture at home. Week 3.1. No, week 3, 3.1, 3.4. So multi-period binomial model from here to here. So any question about this? Do we have anything to discuss about this?
You made one mistake.
Beg your pardon?
You made one mistake.
Mistake?
Mistake.
Which mistake?
When you talked about the die game, you wrote down 4.5 and 4.5.
Oh, okay. So
It's just a little one, but and it's not on the slides. It's when he writes it.
so it is not a slide.
It's not on the slides.
Oh, you are very careful. Thank you. I didn't know this.
But I like this professor much more than the other one.
Oh, yes. Most of them are good, but yeah, he's slightly better. Yeah, I agree. Multi-period model. It is basically assuming that we understand fully the one-period binomial model. And then last week we briefly talked about the replicating portfolio strategy. Do you remember? And then I also introduced risk neutral evaluation based on risk neutral model. They are very straightforward, do you think? Any questions? 김민영, anything about last week's topic? Not last week, 2 days ago. 다 이해했어요? interest rate goes up. So in the binomial, that's good question. Our binomial tree model we assume the interest rate is flat. Interest rate is at least. And then later on, we will run fixed income binomial tree. And then indicate interest rate change. But for the time being, we assume interest rate is fixed. Any other question? 또 질문 없어요? It is okay, very important topic. Okay, so since it is important, 주인장 질문 없어요? 무슨 말인지 알겠어요? 이태원 학생은 뭐 지난학기 배웠으니까 질문 없고. 이거 what is risk mutual value예요? 주인장. Do you remember the procedure of valuation? Risk mutual valuation. Yes, exactly. And then just need to explain. Let me run the class. Stock price, red, interest rate, 1.01. Then we have up, down, probability is P, 1 minus P. Then future price, future stock price is so return is remember this, right? So if we invest and then option price is when stock price go up, it is 5. When it goes down, it's 0 because exercise price is 102. So it is settled. And our question is, what is the price of the contract that generate $5 in up scenario and $0 in down scenario? That is our question. So our strategy is invest X in stock, and then invest Y in cash. If we invest X in stock, then we have this one multiplied by if we invest Y in cash, then it is risk-free. So if we invest Y, we will have Y multiplied by 1.01. Therefore, our portfolio value is this one since we invest X dollar in stock and Y dollar in cash, so in up scenario, the value of our portfolio is this one, and it is down. So it is a kind of cheesy analogy, but I make an analogy that because of the price of pasta, we are replicating pasta then if we invest in stock is good, and then cash is good, and then I buy X value of and Y value of pasta, and the value of pasta 5 is we want to match this value of portfolio with this one. Then they do the replicate of option. So in this case, the value of portfolio is the value of option. So it is we want to match this one with this one. So it is a two equation, two unknowns. So we can solve it. Yes.
Concerning the risk neutral probabilities, it was also there was no arbitrage, right?
Yes.
When they played around with U, R, and D, what's bigger, what's smaller, etc.
That's the question. Okay, my original plan was to skip that part, but since you see, I'll explain it. Okay. Well, let's finish this one. Then, in order to solve X and Y, and the matrix algebra is this one, this one, this one, and then X, Y should be this one. So X, Y is basically this one, inverse of this one, 5, 0. So I want to do M inverse and then M inverse right? So X plus Y. Now value of option is this one. Okay. Alternative approach is risk neutral valuation. So risk neutral valuation is like assuming that we are in phase of approach that we assume that we are in the risk neutral world. So suppose we are in the risk neutral world. If we are so in this real world we are living, everyone is risk averse. We hate risk. But let's use some imagination that everyone is risk neutral. If everyone is risk neutral, and it means that people don't care risk. But in finance, we know that when we make investment, we use risk and income. And since we don't care risk, because everyone is risk neutral, then we only care return. So people from the asset they generate high return and short the asset lower. Therefore, in equilibrium, every asset is significantly sensitive. People are risk neutral, right? And then, question is of course, at which return? Every asset will generate the same expected. And then we at least know one return which is risk free. So in the risk neutral world, if people are risk neutral, then they will invest only on return, therefore expected return of the whole asset should be same and same risk free rate. Okay? So suppose let's think about stock, okay? If we invest in stock market, if we invest stock, then 1 year later, the value of our stock would be it should be something like this. U is this return, up return, and this down return, right? So if we invest the less option, Q is the probability of going up. So this probability, real probability, the stock price will go up, and this probability Q is the probability going up in risk neutral or the hypothetical. So if we invest in the stock market, if we invest in the stock, then 1 year later, the expected value of my stock would be something like this. Right? Any question? Tomorrow, stock price should be something like this. Right? Any question until now? No. And then instead of investing in the stock, we can invest in the cash. And it will generate the risk-free rate, which is, let's say it is R, stock price is S, and the risk-free rate is it's very annoying. I don't know how to. This is annoying. Okay. This is terrible, but uninterested R. So if we invest in cash, then we will have RS. R multiplied by S, right? So this is something we get in this calculation if we invest in stock. And this is something we get if we invest in cash. But since people are risk neutral, and then in equilibrium, every asset should generate exactly the same expected return. So therefore, this one and this one should be same if people are risk neutral. If they are same, then this one should be same to this one on the risk neutral world, and then we can solve this one, and S cancels out, blah blah blah, and then therefore Q becomes right? It should be this one. This is one equation and one of and then even in option pricing, I mean, I told you every exactly same because so if we invest in option, okay, if we invest option, let's say C is the core option, value of core option, and T plus 1. If we invest the core option, then of course the expected value of this option is when stock price go up, option generates something like a CU. CU is a 5 in this case, right? It is the value of core in up scenario, so I bring CU. And then if stock price go down, the value of option is of course 0, which I will call CD. And then so this is something I get if I invest in option. But instead of investing option, we can invest in bank. If value of call is a C, then it generates something like this. So this part is something I get if I invest in option. This is something I get if I invest in cash. And then this now we know this one is 5, this one is 0, we know 2. Our question is what is the C today? And we know what C divided by the answer. So therefore C is equal to R, right? Something like that. And then interesting result is that we need this value is dimension. So we can check it. So Q is U R minus D down return divided by U minus D. Yeah. And then 1 minus Q is 1 minus this one. Therefore, expected value of C is, okay, I can use some product, but this one multiplied by this one plus this one multiplied by this one. Right? So this is expected value. And then actually I prefer some product. They are same? No, not same. 네? 처음에 계산이 틀린 거였어요? This one multiplied by this one plus this one. This is 0, so okay, this is right. Okay. And then if I discount it back, this is exactly same. So we have very interesting and very important results actually. Right? Again, this is the very intuitable I replicate option and omega get value. And this is something more interesting. In this case, instead of using this replicating approach, okay. 돌려. 이거 진짜 중요한데, 돌면 안 돼. You shouldn't sleep in this important lecture. This is highly important. This is too valuable. I mean, content to sleep away. 돌리면 일어서서 들어. 뒤에 나가서 일어서서 들어도 되고. 여기 의자 갖고 와서 앞에서 들어. 우리 때는 공부 못하거나 수업 태도 안 좋으면 너 책상 가지고 나와야 돼. 조윤정 학생 때도 그랬나? 그러지 않았어? 아, 김민정 학생 막 그랬나? 아, 고등학교 때 그랬구나. 역시 수업 때도 안 되고 너 책상 들고 나와서 앞에 따로 수업 때. 이게 서서 if you are sleepy, you just stand up. Okay? That's the best way. And then, okay, so this is rapid. So everyone understands this procedure, right? This is simple, right? Two equations of and then we have another very interesting value. In this case, we are assuming that we are in the risk-neutral world. And in the risk-neutral world, every exception is the same result. This is the risk-free. And then if every result is exactly the same result, then probability go up should be something like B. And then once I get this probability, then okay, stock price go up, then pay this one. And stock price go down, then pay this one. And then so I get this value, I discount it back, then exactly we get option price, which is exactly this is very weird. First one is intuitive, and we are basically assuming that we are living in some other world, some imaginary wonderland, and we calculate the value of option in imaginary wonderland, and that value is exactly the real value. Right? This is not real world. We calculate option value in some strange world. And then thing is that option value that we get at the strange world is exactly the same to the value of option in the real world. This value of option in real world, and this is the value of option in imaginary world. in which everyone is visible. How we option valuation is very interesting. And this is so interesting that Barton chose the Nobel Prize uploaded. Before they got Nobel Prize and before they published it, they didn't even imagine this kind of valuation. Because we didn't imagine it. We have to imagine that we are in a narrow world and we get the valuation. We can actually prove it. We can prove it. Right? So that's the proof. So in this case, okay, value of the option is in a replicating approach. It is a U, D, R, inverse, CU, CD, right? CU is 5, CD is 0, right? And then inverse matrix is in high school mathematics, we know how to get the inverse of this one, right? If I remember correctly, there is D over 1, and then what? I have to change it because R U and minus R minus D, and then CU CD, right? And then D is, of course, D is determinant of this matrix. U R minus T R, right? R U minus D, right? Right, I think it is. And then create a mo형2. You didn't forget this, right? Of course, it is a long time ago since you graduated high school. And then C is what? R. Okay. R C. Then DCU. So, okay, so in mathematical algebra, we can piece by piece. CU is this one, this one. CU is R minus D. CU plus D is this one, so B is this one, so U minus R. And then D is this one, so it is like R, then I put this R, this one, and then this is X and Q. So I prove that it is mathematically equivalent, that we calculate option in the real world, and we can do option value in hypothetical world. In the Q is probably going up in that hypothetical world. So I have to prove very interesting. And then of course there are slight issues. I argue that Q is probability. Q is probability. If Q is the probability, Q should be between 0 and 1. So the question is, right? And then Q is okay. So first we have to check whether Q is 0 or not. And then in order to prove that, we usually think, what if Q is not in this region? Okay. Suppose Q is less than 0. What does it mean? if Q is less than 0, when Q is less than 0? Why? If Q is less than 0, it means that U is should be greater than D. So if R is less than D, Q is less than 0, right? So it is possible that R is less than D. So if R is less than D, less than equal to D, of course, if probability can be 0, but then Q is 0. And I think that this shouldn't be possible. R is less than 0 means that whatever happens in future, D is the worst return, right? Even the worst return is greater than risk-free rate. So I think this is very good asset, right? Everyone wants to invest in this asset because they at least return greater than bank. So what do we do strategy to make money? Not only invest, we borrow money from the bank and keep investing in the stock. In the future, the worst possible case, still I get a higher return than the bank. So I make money and keep the pay back to the bank. So it means there is R in the future. Actually, even if this is equal to this, still there is arbitrary. If R is equal to this, worst possible case is same to worst risk-free rate. So still, therefore, even in worst possible case, I don't lose money and I will positive probability of making money. Therefore, still it is arbitrary. So Q is greater than 0. Next, what if Q is less than 1? If Q is greater than 1, if Q is greater than, then R is greater than 2. And this is also not possible. If R is greater than the best possible asset return is still lower than risk-free rate. So I always lose money. In this case, the best strategy is simply short selling and just invest in the bank. Okay, then if I short sell, the worst possible case is stock price going up, but still it is lower than risk-free rate. So I simply out the money from the bank and pay out to my short position. And then again I make infinite amount of money. So as far as there is no arbitrary condition, this should always hold. Okay? So no arbitrary condition, this kind of Q exists. If this kind of Q exists, this kind of risk neutral world exists. And if this kind of risk neutral world exists, we can calculate motion value with this risk neutral value now, and then it is exactly the same true value. So as far as there's no arbitrary condition is very important. No arbitrary condition, then we have risk neutral. We can use imagination, and then both will be the same. And then when we say expectation in this case, it is we are calculating expectation in the risk neutral world, right? Which is not real world. So in order to check this is not risk neutral, which is risk neutral world, we put usually Q over here. Q is this Q, this kind of Q, because we want to specify that we are calculated, so we don't want to be confused. So that's why we put Q. And in Excel, I can Q over here. Yes, this is good. So the purpose of the well-told approach, risk neutral valuation approach, every asset price is equal to expected value of future cash flow, but on the risk neutral world. You know, I explained this word in the last semester, and in this report. This is similar to movie Inception. watch Inception movie? No? Leonardo DiCaprio. No? Did you watch Inception? Did you watch Inception? No? Inception is movie of, did you watch Inception? Did you watch it? Okay. Inception is kind of, there are a bunch of gangs. There are gangs. And then they are very interesting. Their business model is like, they make money like this. They go into other people's dream. Okay? They go to other people's dream. And then in the dream, they manipulate people's mind. And then in the dream, if they manipulate people's mind, and people's action change in the real world. And then one interesting part is that when they go into other people's dream, and then in that dream, they go into another dream. So there are second level of dream. So basically, I sleep and I am dreaming, and in the dreaming, I'm sleeping again. Since I'm sleeping again in the dream, there is another dream in the dream. Something like that. More interesting, there are dream in the dream, in the dream, in the dream, something like that. There are levels of dream. Very interesting. So, and then of course we have to come back to real life someday, right? And then so therefore they have to wake up sequentially. They wake up, right? So there's this is very interesting movie. You should watch it. It is a great movie. Very interesting. So there's people and sleeping in a dream, and in the dreaming they sleep again, dream, and then dream, something like that. And then they should wake up, and then wake up, and then wake up, and then wake up, and they go back to real life. Thing is that since go dreaming, and they get confused. Okay, right? They are in the 1 level, 2 level, 3rd level of dreaming. They should wake up 3rd time, but I mean in the multiple dreaming, they may confuse whether they are in the 2nd level dream or 3rd level dream. Even they confuse that whether they are in the dream or real life. Right? But since they are in the 3rd level of dream and they confuse that they are 2nd level of dream and wake up only 2 times, they are still in the dream. And another important thing is even if they wake up, still they think they are in the dream, right? They are now 3rd level of dreaming, and they wake up 3rd time and they are in the real life. But maybe they assume that, oh, actually I was in 4th dream, although they are in the real dream. So they wake up 3rd time, they may think they are in the dream, although they are real life. So if they are in the dream, they think they are in the dream, but they are in the real life. And if they recognize if they assume that if they misunderstand that they are in the dream, they may jump off the platform, or they need to do very extremely stupid things in the dream, right? Because it is dream, in the dream they can do anything. I mean, what are you? Suppose you are dreaming and you know you are dreaming and you can manipulate anything in your dream. What are you going to do in your dream? You can do all the crazy things, right? Yeah. We can do all the things we imagine. I mean, all the yes, something like that. And that happened in the movie. The wife of the Leonardo, because she thinks she is in dream, but actually she is in Leonardo, and then she jumps off the apartment, assuming that she is the dreaming, and then if we jump off the apartment, and then she walks out of the dream, but of course it is real life, so she died. So there is they need a device, okay? They need a device to tell that whether they are in dream or not. And one of the device, they spin. And so they spin. Then you spin the top, and then if top doesn't fall, then it is dream. If it spins forever, then it is dreaming. And it is not. It's real in real, of course. top Q4 eventually because eventually it's top right. So we need to divide by the top Q. And in this case, this is the threshold Q. So we should be confused. So we should. So Q is the expectation. Because we have to know that we are in the imaginary dream, right? Risk neutral world. And we are being valued from there. In the movie, in the movie, the time for the total, and everyone has a different. But in the file, everyone will be similar to the Q. So anyway, watching this is a great movie about derivatives. That's my interpretation about it. So in the movie, there is analogy with this approach. And in the movie, in the dream, they manipulate people's mind, and it is actually real change the real behavior of people. In this case, we calculate the ocean value in imaginary world, and this is actually real value. So this is one-step valuation, and then in the multiple step, okay, multiple trees. So it is binomial tree. Please, where is the? This is one period. Okay, so in case of a multi-period model, multi-period model approach is basically same. In case of option price, so this is dynamics of stock price. In case dynamics of stock price, so we have only two scenarios, and then there were three scenarios, and we have four scenarios. Okay. So in case this kind of 3-period binomial tree, our approach is basically similar. Okay. Of course, in 3-period binomial tree, we have the option price like this. So this is for option price. This exercise price is 102. Right? So option price is 22.5. In this case 7005. And then in order so in the terminal period, it is European color. So the terminal period option price is like this. And then our question is, what is the value of option that generates this depending on scenario. Okay. Then we take the approach of Liogan intelligent approach. We go into the dreaming. So we are in the risk neutral world. So okay, we are here. Okay, we are here, and then risk neutral world. Every efficient set is the same. Risk free rate. So let's say it is probably Q1 minus Q, and then the stock price we go to Q like this, and we get expected price. Oh, so at this point, option price is there. And at this point, there are two scenarios. We get option price, and then we get another option price over here. Expected value and discount, and expected value and discount, and then expected discount and done. And then we wake up and use option price. And then this is what ready. Yeah. This is what the expected value and discount. And we can keep iterating. Of course, you don't have to go into the training, and then you can be like replicating portfolio approach in every step. Right? And every step you do two equations one thing, right? But there is more. That is not that complicated, but there is more to this cake, and this is not less interesting. It is more interesting. More interesting in the so easy, right? What's going on? I mean, this is the more boring way of explaining this is neutral world. Okay. Instead of watching this one, you can watch Inception. The existence of a risk neutral probability is equivalent to no arbitrary. there is no arbitrary, then we can go into the dreaming. And then pricing of American option is can be exercised every period. So in the previous case, again it is same. We go into the dreaming, and then in this case, we can calculate exercise respective value, and then we get value option. But at this point, we can also exercise option right away. If we exercise option right away, in this case, in the underlying that there is 114.49.